Hello and welcome. In this video, we are going to be looking at solving radical equations, mainly square root with like a cube root here and there. But actually square root's a little bit more challenging, but that is what we are going to be taking a look at today. Something similar to this. Square root of x minus 3 plus 4 is equal to 9. Now, when we are solving radical equations, regardless of its square root, cube root, fourth root, whatever, what you want to do is you want to isolate the radical itself. So in this particular case, we're trying to isolate the square root of x minus 3. What that means is that we have to subtract 4 from each side in order to get the square root of x minus 3 is equal to 5. Now, once you isolate the radical like we already just did, it only took one step in this particular problem. It could take more, okay? But once you isolate the radical, what you want to do from there is you actually want to cancel that radical out if possible. Now, there are going to be certain problems that are a little bit more challenging where it's not possible to cancel out the radical right away because maybe there's more than one. But in most of the examples we're going to cover, it is going to be possible to cancel that radical out because there's only one. Now, in order to do that, you actually have to raise each side to the power of what's called the index. The index of a square root is 2, the index of a cube root is 3, and so on and so on and so on. So basically, in order to cancel out a square root, you must square each side. In order to cancel out a cube root, you must cube each side, and so on and so on and so on. So what we do here is we square each side in order to cancel out the square root, and then that gets us x minus 3 is equal to, well, 5 squared is 25. And then from there, we just go ahead and solve. We may have to factor, use like the quadratic formula or something like that, but for this one, it's actually pretty straightforward. We just have to go ahead and add 3 to each side, and we get, boom, x equals 28. Now, especially with square root and fourth root and sixth root, and as you can see, there's a kind of a pattern emerging. With these types of equations, there are domain restrictions on like square root and fourth root and so on. So we actually do need to check your solution or solutions because in some cases there are actually going to be more than one. The reason is because we can actually end up with extraneous solutions the same way we could have ended up with extraneous solutions with logarithmic equations. And the same way we can possibly have them with like rational equations, which we're going to be covering shortly. So we do actually need to double check our answer. And in order to do that, we actually need to take what we got for x or y or whatever you're solving for. We're solving for x here, but I got to take what I found for x, 28, and actually plug it into the original equation for x and see if it actually works. So that's what I got to do, and that's exactly what we do. We plug in 28 for x, so I get 28 minus 3, the square root of that, plus 4, and I want to see if it's actually equal to 9. And if we go ahead and we do that, we get 5 plus 4 is equal to 9. And yeah, that's true. So that ends up working. So that would be our solution. So that's actually really important. Always make sure you double check your answers, especially for square root equations. It's probably a good idea to do for all of them, just in case you made a silly mistake along the way. But especially for square roots because we can have extraneous solutions. Now that's just a square root equation, right? Let's take a look at a cube root equation. So we have here 4 times the cube root of 2x minus 1 minus 5 is equal to 3. Now, here, we need to, once again, isolate the radical. So this is going to take a little bit more work. We're going to have to go ahead and add 5 to each side to get 4 times the cube root of 2x minus 1 is equal to 8. And then we have to actually go ahead and divide each side by 4 to get the cube root of 2x minus 1 is equal to 2. Now, from there, remember, we have to actually cancel out the radical. We have to cancel out the cube root in this case. Well, to cancel out a cube root, you got to cube each side. Just like in order to cancel out a square root, you had to square each side. So I go ahead and I raise each side to the power of 3. And then what I end up getting is, well, the cube root cancels out to get 2x minus 1, what was just underneath the cube root, is equal to 2 cubed, which is 8. And from there, we just go ahead and solve. Add 1, divide by 2, and we get x is equal to 9 halves or 4.5. 4.5 is exactly equivalent to 9 halves or 4 1/2. So that's why it's okay to write it as a decimal. If it was like 1/3, do not write 0.3. That is technically not correct, okay? Just leave it as a fraction in most cases. It's totally fine. Just see if you can simplify that fraction. But remember, we have to double check our answer. Now, with cube roots, it's actually not as important because the domain of a cube root is actually all real numbers, which means you actually can't really get extraneous solutions, but it's still a pretty good idea just to make sure. So I went ahead and I plugged 4.5 in for x in our original equation. Notice 4 times the cube root of 2x, well, x we found to be 4.5, minus 1 minus 5. Want to see if that actually got us 3? And it did. So that would be our solution. Now, these were actually a little bit more simple, okay? They didn't require any like factoring or a quadratic formula or anything like that. So I want to take a look at a couple of problems that actually do require that. So let's go ahead and take a look at our next example. All right, so let's take a look at our next example. So we have x is equal to x plus 1 raised to the 1/2 power plus 5. Now, for some of you, you might be looking at me and going, I thought we were talking radicals. Why do I see a fraction as an exponent? Well, what you need to remember is that x to the 1/2 power actually is the square root of x. Whenever we have fractional exponents, you're actually dealing with radicals. X to the 1/2 is the square root of x. X to the 1/3 is a cube root of x. So do anticipate seeing fractional exponents and make sure you know that you're actually dealing with a radical here. Okay, so we're still dealing with a square root. So if you want, you can actually rewrite this as x equals the square root of x plus 1 plus 5, or you can just leave it like this. It's entirely up to you. So our first step, remember, is to actually isolate the radical. So I'm trying to isolate x plus 1 raised to the 1/2 power. So in order to do that, I need to subtract 5 from each side. So I get x minus 5 is equal to the quantity of x plus 1 raised to the 1/2 power. And remember, that's a square root. So now I have to cancel out that square root by squaring each side. So I go ahead and I square each side and I get x minus 5 quantity squared is equal to what was underneath the square root, which was x plus 1. Now be careful here, because all too often I see people go x minus 5 quantity squared. Just square each piece, right? X squared plus 25. Wrong. Remember, that actually means x minus 5 times x minus 5. That's x minus 5 times itself. So you actually need to, as so many of you remember it as FOIL, you're actually just kind of multiplying that out. Okay, so we multiply out x minus 5 times x minus 5. That's equal to x plus 1. And that gets us x squared minus 10x plus 25 is equal to x plus 1. Now from here, we actually are going to have to solve by factoring, or the quadratic formula, complete in a square, whichever one you prefer. I'm going to go ahead and factor. I would have to subtract x from each side and subtract 1 from each side, so I get everything on one side of the equation. And from there, we have to go ahead and factor. And this would actually factor to x minus 8 times x minus 3 is equal to 0, which means x is equal to 8 and x is equal to 3. Now, with square root equations, remember, it's extremely important to double check your answers. So you have to do that. So I'm first going to go ahead and check out 8. I'm going to plug 8 into the original problem. It's extremely important that you plug it into the original equation, not once you started messing around with it, okay? We're making sure it works for the original equation. So I plug 8 in for x. I plug 8 in for x, as we can see. And I get 8 is equal to 9 raised to the 1/2 power plus 3. Remember, 9 to the 1/2 is just a square root of 9, which is 3. We get 8 is equal to 3 plus 5. That checks out, so 8 is definitely an answer. Now, that doesn't mean 3 isn't an answer, but it also doesn't mean that it is. So we actually need to double check that. So in order to do that, we just do the exact same thing. We plug in 3 for x in the original equation. And notice we actually get 3 is equal to 2 plus 5, which is just simply not true, right? 3 is not equal to 7. So what that means is that 3 is actually an extraneous solution. We did everything right. We solved for the problem perfectly. It's just that 3 turns out to be an extraneous solution. So our only solution would actually be 8. All right, now I'm going to go ahead and give you a new problem. Let's go ahead and take a look at it. Let's go ahead and take a look at this problem. The square root of x plus 6 plus x is equal to 0. What I want you to do is go ahead and pause the video here and work this one out, see what solution or solutions you end up getting, and then you can kind of unpause the video. I'm actually going to fast forward through all the work and then explain it a little bit afterwards. But be very careful with this. Just make sure you're following all the right steps and you should be fine. Let's go ahead and take a look at what all this work would be. Okay, so what you should have done first for this one is subtract x from each side to get the square root of x plus 6 is equal to negative x. That's to isolate the square root. From there, you have to go ahead and actually square each side. So we square the square root of x plus 6 and we square negative x. And when we square a square root, they're actually inverse operations of one another, so they cancel each other out. So that just gets us what was underneath, which is the x plus 6 is equal to a negative x squared, or the same thing would be negative x times negative x is positive x squared. That you have to be really, really careful of, because if you don't get that, it actually changes the entire problem, okay? Now from there, we go ahead and we have to get everything on one side of the equation, so that becomes 0 is equal to x squared minus x minus 6, or you could have brought the x squared over, which would have had a negative leading coefficient, which is just kind of messy. I kind of always like to have a positive leading coefficient. It just helps out a lot with factoring. It avoids a lot of mistakes. So we get 0 is equal to x squared minus x minus 6. That is factorable, so I'm going to go ahead and factor that to x plus 2 and x minus 3, which means we get negative 2 and positive 3 as possible solutions. Well, when I plug in negative 2 into the original equation, it actually checks out, so negative 2 is our solution. Because once I plug in 3, I actually end up getting 3 plus 3 is equal to 0, which is simply not true, which means 3 is actually an extraneous solution. So negative 2 would be the only answer for this problem. Now, I know all of these equations that we have gone over today only ended up with one solution, but I want you to know that it's actually possible to have more than one solution. It's also possible to end up with no solution. You just need to be very careful with your work and that particular problem. But that's really it. That's solving radical equations. And I know we only covered square roots and cube roots, but pretty much the exact same methods are used in solving higher level radical equations like fourth root and fifth root and so on and so on. So that's it. I hope this video was helpful. If you have any questions at all, please feel free to reach out and let me know. Otherwise, I look forward to seeing you guys in the next video.